Welcome to the JEE Main 2026 Rah Vah Series. In this series, we are going to learn about functions. Okay, let us observe functions. What is a function? If you see the function definition, I like a relation you take first. Okay, F is a relation I am taking. If F is a relation F from set A to set B is said to be a function or mapping, I can call, or correspondence. Okay, all these words are similar: function or mapping or correspondence. When this is going to be a function, if and only if each element of each element A belongs to A, there exists unique element B belongs to B such that A comma B is an ordered pair which belongs to the set, which belongs to the function F. Okay, you see what is that? A relation, a relation. F is a relation is said to be a function or mapping or correspondence. Then from A to B, for each and every element of A belongs to A, there exists B belongs to B. Okay, there exists unique. This is keyword unique. There exists unique B belongs to B. Okay, such that A comma B belongs to F. In this case, the set A, this set A is said to be domain and the set B is called the range or codomain. Okay, set B totally, you take it as codomain only. Okay, set B is called codomain. But whatever the elements which are mapping from A to B, those can be called as range. Okay, those can be arranged. Very good. Let us see. So a relation or from set A to set B is called a function if each element of set A is associated with the some element of B. Each element of A has unique image. What is that? What kind of image? Has unique image in B. Okay, unique image in B. Thus function F from set A to set B is a subset of A cross B, in which element belonging to A appears only one ordered pair. Okay, belonging to F. That is, F is a subset of A cross B. For all A belongs to A comma F of A belongs to F, A comma B belongs to F, and A comma C belongs to F, B is equal to C. That is the meaning. Okay. Yes. Let us move to the every function. I am taking a function. Is every function is a relation? Yes, no doubt. But what about a reverse, converse to this? Every relation, is it a function or not? Let us check. We already checked while dealing with relations. Let us observe now. You see, it is a function. Very good. Because we used all the elements of A and each element has its unique image in B. Very good. It Why it is not a function? Because you see, the image of x1 is y1, the image of x1 is another y2. So it has two images instead of one image. Okay. So it is not a function. It's a function. Then it's not a function. Why? This element cannot be used. Okay. All elements, each and every element of A should be correspondence to the B in such a way that unique image can be appeared in A with respect to A. Okay. That is called the function. Got it? You see, easy ways to differentiate function from relation. Consider every element in set A is a guest and every element in set B is a hosting. So one guest, one host, like that. Okay. One guest can be invited. No, sorry, one host can invite the one guest, like that. So none of the elements can be two functions simultaneously. So if an element is attending two functions at the same time, then it is just a relation. An element is attending, you see, an element is attending two functions. Here two functions. It is not a function. It's only a relation. Okay, got it? So I think you cleared this function and as well as relation difference. And also we observed yesterday, like by observing the graph also we observed how it is going to be a function, how it is going to be a relation, just by drawing the line parallel to y-axis. The y-axis, if the curve, our curve touches the y-axis at two different points, it is not a function. It is a, if it touches only at one point, then it is a function. Okay, we observed this also in the relation part. Okay, and we observed these two graphs also. And domain and codomain also we observed, right? Like the images of first, sorry, the elements of set A are called, is called domain, and the the elements of set B is called codomain. But whatever the elements which are corresponding, okay, which are corresponding, or which are I can say which are making connection with B, those are called range. Okay, the total set is codomain. Range is only the ordered pair, only the elements which are making a set, or which are making an ordered pair, forming an ordered pair with some elements. Those are called range. Okay, codomain and range. Range is a subset of codomain. Okay, all right. Now today we are going to observe the different types of functions. Let us observe the first function, that is polynomial function. If a function f is said to be a polynomial function, defined by f of x is equal to a naught x power 1, like this. This is a polynomial function. N is non-negative integer, and a naught, a1, those are real numbers. A naught should not be 0. You know that. Then f is called a polynomial function of degree n. So f is called a polynomial function of degree n in variable x. Okay. Yes. See here you can see f of x is equal to x square plus 1. Okay. This is going to be here. This is going to be a parabola. Okay. Here f of x is equal to x square plus 1. Another one. Suppose I am taking f of x is equal to ax plus b. This is a linear function, right? Okay. Linear function in which a should not be equal to 0. Similarly, f of x is equal to ax square, okay, plus bx plus c. We know this. This is a quadratic function, okay, quadratic function. So these are the different types of polynomial functions, okay. Domain of a polynomial function. If you see the domain, what is the domain of polynomial function? No doubt it is going to be R, right? Domain of polynomial function is going to be R. We can give set of all real numbers to this polynomial function. Okay, right. A polynomial of degree 1 with no constant term is called odd linear function. F of x is equal to ax, a not equal to 0. There are two polynomial functions satisfying the relation f of x into f of 1 by x. F of x plus 1 by x. They are f of x is equal to x power n plus 1, x power n plus 1, and f of x is equal to 1 minus x power n, where n is positive integer. Domain of polynomial function is what? Or we can give all real numbers to the polynomial function. It satisfies. Next, range. Range for odd degree polynomials. Okay, what I am taking? Odd degree polynomials is R, whereas even degree polynomials range is a subset of R. Okay, even degree polynomials, it is subset of R, and range of odd degree polynomial, it is R. Okay, got it? This is about polynomial function. Okay, right. Next, algebraic function. What is an algebraic function? Let us observe. The algebraic function, y is an algebraic function of x if it is a function that satisfies an algebraic equation. What is that? It satisfies algebraic equation. And that is p naught x is equal to y power n plus p1 of x, y power n minus 1 plus so on pn minus 1 of x into y pn of x is equal to 0. N is a positive integer. P1 x so on are polynomials we know. Okay, y is equal to mod x is an algebraic function. Since it satisfies the equation y square minus x square is equal to 0. Okay, it satisfies the equation like that. Algebraic function and real valued function. Algebra of real valued function you can take. Say, I am taking algebraic function, algebra of real valued function. If you see real valued function with algebra, say I will just a change of definition. Let us take f maps a into b. Okay, this is a function. Okay, first condition is in order to become a real valued function, if a is subset or equal to r, then f is called a real variable function. Real variable function. Okay, a is subset or equal to r. If b is subset or equal to r, then f is called a real valued function. Okay, real valued function. If a is subset or equal to r, comma b is subset or equal to r, then f is called a real function. You understand? A real function. Hmm? So you see, real valued function, algebra of real valued function. I said. So this is algebraic function. This is totally different. But under this, you have algebraic and transcendental functions. A function is algebraic function if it arises due to what? Finite number of fundamental operations, right? Finite number of fundamental operations like addition, subtraction, multiplication, division, those, okay? Square root, polynomial function, okay? A function, suppose, which is not an algebraic. A function not algebraic is called transcendental function. Transcendental, transcendental function. Okay, transcendental function. What is transcendental function? Which is not an algebraic function. Okay, you got an idea like algebraic, that is real variable function, real valued function. Okay, if you see the algebra of real valued function, if you see the properties, the main properties are, suppose I am taking f and g are my two real valued functions, okay, whose domains are a comma b. This domain is a, this domain is b, like that. Then both f and g are defined on a intersection b. F and g can be defined on a intersection b, where a intersection b never phi. Okay. Next, if it is the condition of this real valued function, this is the condition I am taking. Okay, these are the two functions. Then what will happen in those? F maps A into R. Okay, G maps B into R. Then F plus G, F minus G, F G are defined on A intersection B. These are all defined on what factor? A intersection B. That is F plus or minus G, F plus or minus G of X, F of X. So how do we write that? F plus or minus G of X, which is equal to F of X plus or minus G of X, like that. Okay. Similarly, F G of X multiplication also in the same way. If this is first condition, and if you see the second condition, let me take the same setup of the functions f and g. Okay. If you observe the second condition, let me take one thing like f maps, suppose f maps a into r be a function and k be a constant I'm taking. Okay. Then f plus k be a constant, f plus k of x, which is equal to, I can write this as f of x plus k. Okay, this is one. Similarly, f into k or k into f, you can take of x, which is equal to k times f of x for all x belongs to a. The function is denoted by minus 1 power of minus 1 into f is denoted by minus f. Okay, like this we can have different properties. Okay, this is the some constant times if you multiply the function. This is the second case. And the third case is here in the first case we observe the all operations. Okay, here in the next case I am taking like what I say, mm, f maps a into r. Similarly, G maps B into R. Okay. Then C is equal to X belongs to A intersection B such that G of X is not equal to 0. Okay. Then F by G is defined on C. Okay. C, F by G of X is equal to. So if I write F by G of X, this is going to be f of x by g of x. Like that we can write. Okay. Yes. For all x belongs to g. But here one important point, g of x is equal to 0. Then this cannot be defined. Okay. Got it? This cannot be defined. Very good. Next, the important another property is we observed f into g, f by g. Okay. And some constant times that one. Okay, we observed that. And the other one is let me take what I say, f maps a into r, f maps a into r, and I am taking n belongs to n, some n belongs to n, then mod f. Okay, mod f I am taking. Mod f means f power n. How f power n are defined on a? This can be defined as mod f of x. Okay, of x, not mod here, of x is equal to mod of f. Okay, we can define like this, or you can take, because f power n we have taken, no, f power n of x is equal to the same way f of x whole power n, you can write. Okay, like this. Then very important, the last point, last property is, let me go with this is mod function. And now I am taking f maps a into r. C is equal to the same way x belongs to a such that f of x greater than or equal to 0. I am taking like this. So this total thing C never be 0. Okay, then what about root f? Root f can be defined as root of f of x, right? Okay, which is equal to square root of f of x. Root f into root f of x is equal to root of f of x for all c. So for all x belongs to c, I can take. Okay. So these are the main important properties which are under algebra of real valued functions. That is how real valued functions works. Okay, this is about algebraic function. Next, let us move to the all polynomial functions are algebraic but not the converse. A function that is not algebraic is called transcendental function. We already observed, right? In real valued functions only algebra variable and as well as algebra real variable and algebra real function. Okay, a real function means if you combine these two, those can be called as real functions. Okay. Yes. Variable function. Okay. Real variable function. And as well as what is the other one? Real valued function. Real variable and real valued. When real variable A is subset or equal to R. If B is subset or equal to R, then it is a real valued function. If both are taken, then that is going to be a real function. Okay. If those are not algebraic, those are called transcendental functions, and their properties also we observe. Next, very good. Let us see the fractional or rational function. Fractional function. What is a fractional function? Fractional or rational function, you can say. Okay. So, if I take the fractional function, like if it is a function which is in the form of y is equal to f of x is equal to g of x by h of x. It is in the form of fraction. Okay. It can be called as fractional function. G of x and h of x are polynomial and h of x never be 0. Okay. Next, exponential function. Exponential function, or I can say logarithmic function. Both we can call. Okay. Exponential or logarithmic function. Yes, exponential function, actually some difference, I will tell you that. Wait, you see, exponential function, a function f of x, if a greater than 0, right, a should be greater than 0 and x is belongs to r, no doubt, real number set, then f of x, our function, is going to be a power x. F of x is equal to a power x is called a, what do you call, this can be exponential function. So if you draw the graph of exponential function, it is going to be like this. So this is x and this is y. If I take, say I am taking 0, comma 1 is 1 point. Okay. It is going to be like this. Okay. This is called exponential function. Okay. This is, if it, this is the graph, if a lies between 0 and 1. Okay. And suppose I am taking a greater than f of x is equal to a power x. This is also the graph of this only. Here, a power a lies between 0 and 1. Whereas here, if a greater than 1, then how it will be? Just take. If a greater than 1, it's going to be like this. Okay. This is 0, comma 1. Okay. This is x and this is y. Like this we can take. So domain of f of x is equal to a of x. What is domain of f of x? A power x. Domain of a f of x is equal to a power x. What is the domain of a power x here? Which is going to be minus infinity, comma plus infinity. You see, it is going like this, minus infinity, and it is going to be like this, plus infinity here also. You understand? Minus infinity to plus infinity. You can give any values to this. But if you observe the y values, f of x value, you are getting negative infinity to positive infinity. Right? You are giving values like this for x, and you are getting values of y also like infinite, plus infinite, and minus infinite. Okay? Are you getting like that? So when it is possible, you see, this is the question. Domain of a power x is minus infinity to plus infinity. Okay, domain is correct. Domain is correct. What about the range? When you go for the range, it is from 0 to infinity. Why? A greater than 0. Right? If a greater than 0, it is going to be from 0 to infinity only. 0 to infinity only. Okay? Right. Next, this is about exponential function. If you see the logarithmic function, this is also in the same. The logarithmic function, that is f of x is equal to log x to the base a. Okay? Where a greater than 0 and a not equal to 1. This is very important. And x greater than 0. These are the three conditions. What is that? A greater than 0 and a never be 1, x should be greater than 0. If a become 1, it's total 0. Okay. So if you draw the graph of this logarithmic function, it's going to be like this. So the logarithmic function, it's going to be similarly like this. Say Okay, it's going to be 1 comma 0. This is x and this is y if I take. Okay, this is my origin. You take this is, if this is the case, f of x is equal to log x to the base a. What is the condition? 0 less than x less than, sorry, a less than 1. If a lies between 1 and 0, sorry, 0 and 1, this is the graph. If a greater than 1, then what it is going to be? Let me draw it. If a greater than 1 means it starts like this, right? So this is also touching at the same, but it is going to be a greater than 1. Okay. This is for a greater than 1. So if you see the domain of what are the values you are going to give for x, for this log ax. Okay. So it's going to be, you should not give it a 0, right? 0 cannot be considered. That's why open interval. And you can give any value to, okay, infinite. And what about the range? If you see the range we are getting, I can say we can get the range is going to be minus infinity to plus infinity. All the values you can get. Okay. Minus infinity to plus infinity. Got it? Very good. Next, this is about logarithmic function. Okay. Got it? Next, if you go for, this is logarithmic function. We observed logarithmic and what do you say? Exponential function. Okay, right. Next, you see, let us observe the next thing. The next function is some important points. Let us observe. F of x is equal to e power x. Domain is range and r is r plus. Okay, and e power 1 by x domain is, because it should not be 0 denominator. That's why r minus 0 is domain, and range is r plus minus 1. You should not consider my 1. Okay, that's why you are removing 1, because e power, no, that one. F of x and g of x are inverse of each other and their graphs are as shown in figure. You see, if both are inverse functions, f of x and g of x, okay, you take f of x, this one, this is going to be f of x, and this is going to be, it is going to be an increasing function, it's going to be a decreasing function, like that. Like a greater than 1. This is a greater than 1, f of x. This is This is also a greater than 1, but these two are inverse functions. Okay. F of x is equal to a power x. This is increasing. And log ax, a greater than 1, this is going to be a decreasing function. Okay. In the same manner, you can take f of x is equal to a power x. A lies between 0 and 1. A lies between, a is less than 1. In that case, it is going to be like this. Okay. So here what I say is exponential function, the exponential function, if a less than 0, what is an exponential function? Exponential function is going to be, if a less than a greater than 0, a belong, x belongs to r, then f of x is equal to, a power x is called an exponential function. Okay, and then here the logarithmic function is nothing but f of x is equal to log ax. F of x is equal to log ax. In that case, log ax, where a greater than 0, a not equal to 1, and x greater than 0. That is logarithmic function. Okay. In this way, we can observe the different functions. Okay. Yes. Let us see the next function. The next function is absolute value of function. Absolute value. So what is an absolute value of function? Okay. The absolute value of function is going to be a function f of x is equal to mod x. F of x is equal to mod x. Then in that case is called an absolute function or modulus function. It is defined as y is equal to y is equal to mod x. That is, if x greater than or equal to 0, it is going to be positive, right? If x greater than or equal to 0, it is going to be positive. If x less than 0, it is minus x. Okay. If you draw the graph of this, you see y is equal to x. It's going to be like this. Y is equal to minus x, like this. This is absolute value function. F of x is equal to mod x. If you see the domain, what are the values you are going to give for this? Yeah, you can give all R values, right? But what about the range? If you go for the range, R plus, okay, all real numbers, positive real numbers, and including 0, okay, you can give like that. And if you see 1 by f of mod x, for this you cannot take 0, right? So R minus 0 and the range is R plus. Why? Because 0 is not added. Okay. Yes, this is about absolute value of function. Okay. Yes. The next function is signum function. What is signum function? The signum function, a function y is equal to f of x. Y is equal to f of x is equal to signum function is defined as follows. So you can take, or otherwise in simple manner you can say like this. Let me take f of x is equal to mod x by x. This is okay. And if, what is the condition? If x not equal to 0. Okay. If not equal to x not equal to 0, this total thing becomes 0. Okay. And if x is equal to 0, if x is equal to 0 is the signum function or signature function. It is denoted by SGN of x, like this. Okay. The function defined by f of x is equal to mod x by x if x not equal to 0, if x not equal to 0 is equal to 0, then if x is equal to 0 is called the signum function. You see, a function f of x is equal to signum function defined as follows. F of x is equal to 1 if x greater than 0, 0 if x equal to 0, minus 1 if x less than 0. For this function, x by mod x here. But here I took mod x by x. Okay. Anyway, you can take. Okay. Yes. If you see the domain of this is going to be R. Okay. Domain of signum function is going to be R. And if you see the range can be minus 1, 0, 1, right? Range can be minus 1, 0, 1. Right. So signum function is equal to d by dx of mod x when x not equal to 0. In that way also you can define. This is d by dx of mod x which is equal to 0, and then when x is equal to 0. This becomes 0 when x is equal to 0, and this is x not equal to 0, d by dx of x you have to take. Okay. Like this we can calculate the signum function. Okay. Right. Next, if you see the graph, if in signum function, it is parallel to the x-axis. You see, y is equal to 1, x greater than 0. Y is equal to minus 1, x greater than 0. Okay. So it is like this. The graph of signum function is going to be like this. Okay. Right. So signum function mod x, x by mod x or mod x by x, but there is a slight change here. Mod x by x or x by mod x. Any way you can take. Okay. So which f of x is equal to 1, x greater than 0, f of x is equal to 0, x is equal to 0, minus 1, x less than 0. Like that we can take. Very good. Next, let us observe the next function, that is greatest integer function or step function. Okay, greatest integer function. The function f of x is equal to integral function is called the greatest integer function. This denotes integral x denotes the greatest integer less than or equal to x. Less than or equal to x. So here you can take -1 less than or equal to x less than 0. Okay, Greatest integer function, this one, greatest integer function. Okay, in this greatest integer function, if you define like x belongs to R, okay, and the greatest integer function is less than or equal to x, okay, less than or equal to x is called the integral part of x. And x minus 1, you take x minus 1 always less than integral part of x, okay, x minus 1 less than integral part of x less than x, okay, that is the meaning. For all x belongs to R. Suppose for example I take 3.45 integral part, which is 3, 0.3, this is only 0, like that, okay. 5 integral part, it is only 5, that is the meaning. Minus 33, that is minus 33, like that, okay. You can take all the integral parts, okay. Next, if you want to talk about the definition, like a step function, it can also be called as a step function, right? F of x is equal to integral x. If you take such that if x lies between, suppose I am taking my x lies between n and n plus 1, okay? Then it can be called as a step function or greatest integer function, or it can also called as a floor function, floor function, okay, floor function. So if you want to draw the graph of this, because it is going to be a step, no, you see steps, staircase, like that, steps, okay, down and as well as upside. So if you want to see the properties of these, my f of x is equal to integral x, okay, then minus 1, when it is going to be minus 1 less than or equal to x less than 0, okay. And if it is 0, this is 0 when x lies between 0 and 1, and it may also equal to 0, okay. And if it is 1, it lies between 1 and 2, and it may also equal to 1. 2, 2 and 3, and it is also equal to 2. In this, so on, like this we can write. If you want to write domain of f of x, that is integral part, okay, domain of f of x, it is going to be 3R, I can say 3R. Domain of f of x is equal to 3R. And range of f of x is, into range of f of x integral x is z. Range is z and domain is 3R, I can say. Okay. So if I take any kind of one constant, let me take any constant k. Okay. I am taking k as a constant. K belongs to z. Let me take. And x belongs to R. Okay. Then if I take the integral part of x plus k, it's going to be integral part of x plus constant. Okay. Constant don't have any kind of thing. You take constant as it is. And similarly, x belongs to z, then minus of integral part of x. What happens? Minus of integral part of x is nothing but minus x only. Okay. If x does not belong to z. Okay. Then suppose if x does not belong to z, then minus x is going to be minus x plus 1. Sorry, minus x integral part minus 1, right? If x does not belong to z, then integral part of minus x becomes minus x integral part minus 1. This is very important. Okay. Yes. Next, you see the important point. I am taking the two integrals, positive and negative. Positive integral plus negative integral. What do I get? So this is going to be, when you add these two, you will get minus 1 if x does not belong to z, right? If it is equal to 0 if x belongs to z, right? Because integral part means it is going to be totally 0. That's why you are getting 0 if x belongs to z. This is going to be minus 1 if x does not belong to z. Okay, very good. And another important point is integral part of x minus integral part of minus x. What happened? Tell me. You see, if two cases, no, two cases arise. If x belongs to z, Suppose x does not belong to z. I am taking x does not belong to z. Then what will be the case? It's going to be definitely 2 times f integral part of x plus 1, right? Suppose if it is belongs to z, then it's going to be 2 times integral part of x, right? If it belongs to z, this is the case. If it does not belong to z, this is the case. Okay, very good. Next, the important point. Say I am taking one integral part of x. It should be somewhat greater than or equal to some constant k. Then what will be the x value? Is it more than a k or it's less than k? Yeah, definitely it is greater than or equal to k, right? Which implies x greater than or equal to k. But k should belongs to z. Okay, that is very important. Next, suppose I am taking in the same way integral part of x less than or equal to k. Then what happens? X is less than k plus 1. Right, very good. Integral part of x less than or equal to k means x is less than k plus 1. If it is greater than integral part of x, if it is greater than k, then what happens? Integral part of x is greater than a k. Then x is greater than or equal to k plus 1, right? Similarly, integral part of x is less than k. Hmm. Then x is less than k, right? Okay, right. X plus y I am taking two things. That is x plus y if I take. Then integral part of x. Okay. So can I write integral part of y plus x minus x? Can I write this total integral part I can keep? Okay. So this is my integral part, right? Integral part. Then what do I get? I can write this as this x plus y can also be written as integral part of x plus integral starting integral part of y plus x minus integral part of x. Xy should belong to R. Okay, got it? Very good. Next, if you go for integral part of x plus integral part of x plus 1 by n, integral part of x plus 2 by n, so on, which is equal to integral part of nx. What is that? Integral part of x plus integral part of x plus 1 by n plus x plus 2 by n plus so on. If you go on writing like this, x plus n minus 1 by n. If you take the integral part of and if you take the sum, you are getting nx where n belongs to n. Okay. This is about greatest integer function. Okay. Very good. Next, let us observe the next function. Properties also we observed. Next, fractional part. Fractional part also we observed. Fractional or part of a function. F of x is equal to, this is x minus mod x. F of x is equal to x. So domain is R and the range is between 0 and 1. That is 1 is closed interval, 0 is added and 1 cannot be added. Okay. F of x is equal to 1 by x. Domain is R and range is R minus n. 1 and range is 1 comma infinite. Okay. Like this we can define. Okay. Yes. Then next one is least integer function. This is the least integer function. What is that? Least integer function. The least integer function. What is meant by least integer function? If x belongs to R, okay, then the least integer greater than or equal to x, it can be denoted by like this. This is the least integer function. Okay, it is denoted. So I am taking 3.2 least integer function. This is going to be 4. You understand? Greatest integer function is 3. Least integer function is 4. You understand? Difference. Okay. Yeah, if you define this, I can say a least integer function, this is nothing but the x belongs to R. Okay. X belongs to R, no doubt. The least integer function, the least integer greater than or equal to x, and it is denoted by like this. Okay, right. And then let me take f of x is equal to, if x is equal to minus 1, f of x is equal to, these are the conditions. F of x is equal to minus 1. Then minus 2 less than x less than or equal to minus 1, right? If x is equal to 0, what happens? Minus 1 less than x less than or equal to 0. If x is equal to 1, what happens? 0 less than x less than or equal to 1. If x is equal to 2, then 1 less than x less than or equal to 2. If you see the domain, you are getting all values of real numbers, right? Domain is R, and range, if you see, range you are getting only the integers, right? Range is only integers. If k belongs to z and x belongs to R, I am taking one more, the important thing under this only, the least integer function only. Say the least integer function if k belongs to z, okay, I am taking, and x belongs to r, okay. Then x plus k, least integer function is going to be the least integer function plus k, okay. Similarly, k belongs to z in the same way, minus x is equal to minus x, okay, if x does not belong to z, okay, if x does not belong to this k, k belongs to z, if x does not belong to z, if x does not belong to z, then what happens? Minus x is equal to minus x plus 1, okay, you understand? This is least integer function, and that is greatest integer function, okay. So you take in fractional part of a function, I want to give one example here. You take in fractional part 3.145 I am taking, okay. What will be the fractional part? 0.145, yes, suppose I am taking the fractional part. Here fractional part means you have to take this like, okay, fractional part of 3 I am taking, it is going to be 0. What is the fraction? 3.0, right? 0. So if I go with fractional part of minus 3.4, what will be the answer? Fractional part of minus 3.4, minus 0.6. I can write this as minus 3.4 minus 0.6 plus 0.6. Can I write like this? Yes? Okay. So then what do you get? Minus 4 plus 0.6. Am I right? So what I am getting finally? 0.6. In this manner, you can solve the fractional parts. Okay. So f of x is equal to x, x minus x, x minus x. F of x is equal to x, you take fractional part, then which is equal to x minus fractional part. If you take, this is the graph you are getting, okay. So these are the different functions: modulus function, okay, fractional function, least integer function, greatest integer function, and one more important function, implicit function. F of x comma y, implicit function means f of x comma y is equal to 0. Suppose this is an equation in two variables, right? So here two variables x comma y, okay. Then this y is called implicit function of x. Y is called implicit function of x in f of x comma y. Okay. For example, 3x cube, you can take like this: 3x cube minus 4x square y square plus 2xy minus 7 is equal to 0 is an implicit function. Okay. Like this. So we observed all the functions like exponential, implicit, constant function. F is equal to k is a constant function. Okay. So range of a constant function is always singleton set. Okay. Range is singleton set. And constant function is zero polynomial. Can I call that zero polynomial? So zero polynomial function has range singleton set. Okay. Got it? So these are the different types of functions. So observe the different functions clearly one by one. And identity function, one more important type. Identity function means A be a non-empty set and F maps A into A. That is called identity function. In that case, f of a becomes a for all a belongs to a. Okay. So this is called identity function. What is it called? Identity function. Okay. So a is equal to, suppose a is equal to 1, 2, 3, 4. We observed already. 1, 1, 2, 2, 3, 3, 4, 4. That can be called as identity function on a. Okay. And composite function, more than two functions. Suppose f maps a into b. Okay. F maps composite functions. F maps A into B, and then next you take G maps B into C. Okay. Then two functions, then the functions denoted by G circle F. Okay. G circle F of A, if you take, that can be called as compound function. G of F of A, we can call, for all A belongs to A. This is called composite function. And then equality functions, suppose equality functions are those functions in which two functions are going to be equal. F of x is equal to g of x, like that. Okay. Hmm. So this is about, and then even and odd functions. Okay. What is an even function? F maps A into R. A into R is said to be an even function if f of minus x is equal to f of x. This is an even function. Okay. And odd function is, what is an odd function? F maps A into R. The same thing you are getting. F of minus x is equal to minus f of x. Okay. Minus f of x for these two, for all x belongs to A. Okay. So these are even and odd function. Okay. Even and odd function, extension of a function is also there. But the graph of even function is symmetric with respect to y-axis. The graph of even function is symmetric with respect to y-axis, and the graph of odd function is symmetric with respect to origin. With respect to origin. Okay, that is very important. And every function you can express in even and odd functions, right? So f of x is equal to f of x plus f of minus x by 2 plus f of x minus f of x, f minus f of minus x by 2, like that. And also, even function is becoming even when you take a plus and into operations. Okay, if you go for operations of g and f, even, odd, like that, you so if you take odd and even, or even and odd, you are getting g plus f is neither. Okay, and G circle F is even you are getting. Okay, only for odd and odd functions you are getting odd. For G circle F. For G circle F, odd and odd only you are getting. For odd and odd only you are getting even. For odd and odd only you are getting odd. For remaining all you are getting even. G circle F. Whereas for G plus F, even you are getting even, and odd you are getting odd, and odd and even if you interchange you are getting neither. Whereas for G into F, it is going to be, if both are same you are getting even, if you are different you are getting odd. That is even one odd you take, that is odd. Okay, if you take both even or both odd you are getting even. Okay, those are the different functions. Okay, these are the different functions. Very good. So different functions, if you know it, then you can easily draw the graphs, and then we can observe the important, next we will observe all the one-to-one function and the injection, surjection, all those. Okay. Okay, then thanks for watching.